Students, this question is asked in NEET 2015 from chapter 5 of class 11, that is from the chapter of work, energy and power. On a frictionless surface, a block of mass m moving at speed v collides elastically with another block of same mass m which is initially at rest. After collision, the first block moves at an angle theta to its initial direction and has a speed v by 3. The second block's speed after the collision is how much, students? We have to find out. Okay? First block has mass m and speed v, students. And suppose, let us draw the situation. Suppose this is the first block. Okay, student? This is of mass m, and suppose this is moving in this direction, and there is another mass of another block of mass m. Here another body of mass m here. It collides with it. The initial velocity of this mass is v. Let us write it here. It is moving with velocity v, and its initial velocity is, student, 0. Okay, and after the collision, so this is the original direction of the mass 1. It makes an angle theta with the direction and proceeds in this way. Okay, this is the angle theta. This is m, and this is suppose say m1. That is equal to m, of course. Okay, student, the first mass, and the second mass, suppose this comes in this way. We have to find out the second mass speed of this mass. It is asked. So, student, and what is the speed given of the first mass? It is given v by 3. You observe here the collision is elastic. That means, student, the kinetic energy is conserved. That means the kinetic energy of the particles before the collision is equal to the kinetic energy, sum of the kinetic energies after the collision. Okay, student, what is the kinetic energy of the particles before the collision? Here, the kinetic energy of the first block is half m v square. Okay, student. And what is that of the second block? That is m into, what is its velocity? It was initially at 0, so this is 0 square. Or this term is totally 0, the kinetic energy of the second block. What is the kinetic energy of the first block, students, after the collision? This is moving with v by 3. Okay, students. So, we may write that half m v by 3 square. And what is the velocity? Suppose the velocity of the second block be v2. So, student, we may write here the kinetic energy of the second block after the collision as half m into v2 square. Okay, student, because it is having also mass m. So this is the equation. This is the kinetic energy of the particles before the collision. This is the kinetic energy of the particles after the collision, and both are same because the collision is elastic, students. So, students, this is 0. We may erase this term and let us divide the equation by m. So m will be gone, m will be gone from here, m will be gone from here. What you get? We can also take the half, everywhere there is half, we can erase out the half also. So the equation we got, v square is equal to v by 3 square plus v2 square. Or we may write this also as a student. This equation can also be written as v2 square is equal to how much? That will be equal to v square minus v by 3 whole square. That will be equal to v square minus v square by 9. That means 9 and 9 v square minus v square by 9. That is 8 v square by 9. This is v2 square. So if v2 square is 8 v square by 9, then what will be v2, student? v2 will be root over 8 v square by 9, or this will be 2 root 2 v by 3. Okay, student. And what is it? 2 root 2 v by 3, that is in option C. So the velocity of the second particle after the collision will be 2 root 2 by 3 v, where v is the velocity of the first particle before the collision, students.